As promised, here's the circuit for the permanent magnet motor generator KickStart Boost controller circuit diagram. Okay, and the purpose is to reduce wind speed of a wind generator cutting speed to about 3 to 3.6 meters per second, or about 10 to 13 kilometers per hour, from about 6.9 meters per second, about 25 kilometers per hour. Okay, so here we go. The main sensor, I guess, of this thing is the anemometer, and the anemometer has a a little bit shadow here. Has a, let's do it over here, reed switch. It gets activated as the magnet goes around. Okay, so I started with one, the anemometer. Then I added another one that's mounted on the generator shaft, and then I just connected them in parallel so that there's more. So I just mounted the magnet on a shaft in the back, and put another reed switch there, magnetic reed switch, and yeah, I did it like this since I only have 3 wires coming from the generator. So I have the ground, I have the red positive, and I have a shield. So actually this here is coming from the shield. So between shield and the ground, which this is the black, and this is the shield wire. Okay, so we have a LED diode, resistor, and this is plus battery. Red connection, just because I have a four wire cable. So I have shield from the generator, I have the black and the red, and then so this is actually the green, and it's coming down on a shield, but it's a green going to the controller. Okay, so in order to be able to get a one shot, we use 1 micro capacitor, and this can be electrolytic or regular, whatever you have. Okay, and then we have a trim pot, 20K. That's so that I can adjust the charge discharge time of the pulse. And this goes into a base of an NPN transistor. And I have another LED just to indicate that we're getting the pulse. Okay. And this goes to positive 12 volts. So on here, once we get the one shot, because this could stop anywhere, could stop right on a magnet, and if you don't have a one shot, it would always be on charging capacitor or whatever, so it would be a very long pulse. Okay, so then I have a diode here. This diode is just a signal diode, like 1N914. This is 2N3904, or equivalent general purpose NPN transistor. It's not critical. Okay, then over here we have our pulse duration capacitor. This one is electrolytic, 10 micro. Mine is 16 volts, but that should do it. Okay, so then we have another trim pot here. $20K to just charge this discharge of this capacitor, followed by a 2K9 resistor to a base of NPN transistor that's part of a Darlington hookup. To get more gain on this signal, to be able to get more amps. So you're gonna go up to like 10 amps. This here is a BU 4522 transistor, capable of 10 amps, lots of volts. Anyway, it's quite enough. Okay, and this one here is mounted on a heatsink. Okay, this one here is also 904 general purpose. This one is not critical either, and any power transistor. Nothing special. Okay, actually over here we do have a relay contact based on the speed, number of pulses here, turns on this stage, which actually pulses 12 volts to the generator. So the generator is right here. So this is PMG. Okay, and from here we also have a LED. You can choose what colors you want. Okay, the resistor is usually on the other side, doesn't matter. This one, in my case, happens to be amber, and this one is green, and that one is green. This one I made a little smaller so that it's a little brighter, as it just gives a sharp pulse. 680 ohms. Okay, so far we got the kickstart stage. So this is the kickstart. Kickstart. And as I said, we're going to have this relay come in when there's enough wind speed, and that's adjusted by another trim pot that we're going to show later. So this is just for the pulse. Okay. Alright, so I'm just trying to make sure that I don't run out of room here. So from here, so this is the connection. That's a yellow wire, and it's a connection actually to the positive of the generator, the windmill generator. So kickstart, this is kickstart. Okay, so then from here we gotta fit in a lot of stuff again. So we have a rectifier diode, isolation diode as well. That's 25 amp. It's part of a rectifier bridge, but it can be a regular one, and could be even less depending on your generator. Okay, so let's draw the next part, which from this signal we have another diode, isolation diode, which is just a signal diode. It's not anything heavy. So this is 1N 914 or equivalent. It's not critical. Signal diode, 200 milliamp, 200 volts, whatever, it doesn't matter. In this case, it can be very small. Okay, next, what do we have? Well, we can go down 2 ways. Let's draw the driver circuit first for the kickstart minimum, and that goes like this. So we have 100K resistor going to NPN transistor, again 2N39 or 4, general purpose, non-critical, and this goes to a trim pot again, the same 20K trim pot. By the way, these here, if you don't know how, so many, you can even omit this, can be anywhere between 15 and 18K, not critical. And this one here, you could just go to 5K 6 or so, and it's going to be sufficient signal. Okay, so this here is divided network that's coming all the way from here, from this signal. So you can just, let's see, let's go all the way over so they then interfere with other parts. Okay, this here is AK2 or 10K, non-critical again, just depends on what kind of range you're gonna have. And then again we have a 68 microfarad 16 volt capacitor, electrolytic, and that's gonna create a turn-on signal. Which actually in this case is going to forward bias the Zener. The Zener made up of a transistor. Okay, so if you have, you can put in 8.5, 9 volt, even 12 volt. 12 volt might be a little bit too high. Zener diode on here. So my Zener diode is like this. This is a make sure I got this right. Okay, so this is a PNP. Junction. You can do it either from PNP or NPN. So this being PNP junction of 22N 41 22 or equivalent. So this creates a reverse bias junction, acts as a 8.5 volt Zener. So this one is not connected anywhere. Collector. So emitter and base is the so this is plus of the Zener and this is minus. Okay, and this we drive into another Darlington transistor setup. PNP in this case. So in case, okay, so this here is the minimum cut in speed section. Okay. In case you had only NPN that you wanted to use instead of this Zener, 8.5 volt Zener, you could also use NPN. So in that case it would be base, emitter, so this would be plus, this would be a minus of 8.5 volt zener. Okay, so you replace the zener with this, if you don't have it. If you have it, just put in a zener. Okay. Alright, so let me make sure I'm going to have enough room here. Okay, yeah. Here's what it is, we'll have to make it work. This is the PNP. And this is PNP. That's also connected to battery plus. Then we have the collectors. The collectors are connected together. And then we have 2 relays. Connected on here. Going to ground. So kickstart. Kickstart. CR. And boost. CR. Okay. It's going to be a little cramped here. And then also on here I'm going to squeeze in another LED. To show this one can be red LED, showing that the boost, this again is a 1K resistor. Okay, now the contacts, okay, the boost contact is here. So what we have here is we have minus 5 volt switching power supply. Then we have the contact and we connect here 5 volts DC. So it's effectively right across the rectifier. So when this is powered on with 5 volts, it basically adds 5 volts to what's generated on a generator and adds it to the voltage. So this here goes to plus system 12 volts. So what's connected on here is the solar panels, the grid tie inverter, the solar MPPT regulator. Okay, I'm not sure if I'm going to draw that here because it's going to get too messy, but I will show you the diagram here. This is the first version iteration, so it's kind of messy, but this is what I'm talking about. So this is a block diagram. generator booster 5 volts DC across with contact boost CR. Okay, and this also goes to kickstart circuit. Okay, and there is the plus system voltage. So what's connected to that is the solar panels. So that's plus 12. Grid tie inverter, it's hooked up to 120. The MPT regulator that goes to the batteries. Okay. Alright, so let's see what else. Okay, so we can identify these. So this is again 2 and 4122, the both is same transistor. And this is power transistor B761. Just to handle more current, 2 relays, basically about 80 ohms each, so 40 draws about 0.3 half amp. Okay. 94. Let's see what else I'm missing. Missing anything? Okay, so this one is not connected. Okay, let's see. I think we have everything. That's it. On the next one, I will show you the operation when there's sufficient wind to start this. So we're looking for wind between 3 to 3.6 meters per second to demonstrate this. So we're going to see the minimum cut-in speed. That's going to turn on the kickstart, this part of the circuit, and also the boost circuit, which is so let's show this somehow without confusion. And so here's the kickstart. I'm just going to draw a dotted line. So this is kickstart CR contact, and this one here is a boost CR contact, and let's show a dotted line. So that's the contact off of here, normal open contacts. Okay. So this is again PMG read switch. This is and then now emitter read switch. The one thing with these read switches is they're quite slow, and they are bounce. So that's why we needed this one shot. Don't tell me I didn't record anything. Oh my goodness. Well, here's the schematic, but I didn't record my explanation. Okay, so here's the explanation of the circuit. And sorry about the shadow. Okay, so this is a diagram. And I did explaining as I was drawing it, but I didn't have the camera running. Okay, so it's a permanent magnet motor generator, windmill, wind generator, KickStart and Boost circuit diagram. And the purpose is to lower the cut-in speed of the wind generator, turbine, or windmill to 3 to 3.6 meters per second, 13 kilometers an hour, from 6.9 meters per second with this particular windmill. Of course, it depends on your windmill. Okay, which is about 25 kilometers an hour. Okay, so the main thing of the circuit is, or the heart of the circuit is the signal that comes from a reed switch, a magnetic reed switch that's mounted on an ammeter vane. Okay, every time it turns on, it gives a pulse. So one pulse every revolution. So and the cup type of on an ammeter turns with the wind speed, with the speed of wind. Okay. So basically, you can figure the wind speed from it. It won't go faster, whereas the blades sorry, I would sketch of a generator. They're going to spin faster than the wind speed, up to the tip of the blades can go up to 7 times faster than wind speed. Anyway, that's just a side note. Okay, so we have a reed switch on an ammeter. I also have a reed switch on the generator itself, on the back of here, magnet on the shaft, and one of these reed switches. That's also used just so I get the better signal. I might separate them later so that I actually can figure the speed of the propeller, but I have ideas. So about 110, 120 RPM, this kicks in. That's the minimum cutting speed. So that's about 13 kilometers an hour, 10, 11, 13, 12, 13 kilometers an hour. And the purpose is to get the boost. Choose right here. Let me try that boost, which is right here. and what this does is adds 5 volts in series with the permanent magnet motor. Okay, and that's the relay contact that kicks it in. Alright, so we have a LED diode with a resistor going to the switch. Switch is grounded. Okay, so we have a voltage here. When this closes, we create a pulse because it discharges the capacitor, and we get a pulse in here, one shot. Okay, this adjusts the pulse length, or how fast it charges, really, so kind of pulse length. But anyway, we just need a one shot, so we get a one shot here. We have another LED diode. You can make that green. Green can be any color, really. Okay, with a transistor, we have a 10 microcapacitor, and then we have a 20K trim pot that if you don't have it, you can put a fixed resistor of 15 to 18K or so. This adjusts the discharge, so the length of the pulse. Alright, limiting resistor, NPN transistor 3904, or any other general purpose NPN transistor, hooked up in a Darlington configuration with a BU4522, which is a power transistor. Again, NPN handles about 10 amps of current and plenty of volts, just to when the minimum cutting speed is on, it will kick these pulses that are coming through into the generator, and it will ease the tension. It will actually start turning a bit, so that it can easier start spinning. So the wind is coming at certain speed, about say 10 kilometers an hour. It would not start without these circuits. It would only start, as I said, at about 25 kilometers an hour. So more than twice the speed to start by itself. So when this kick starts and the wind is there, 12, 13 kilometers or more, this will kick in. That will start pulsing it. So this will start turning easier. So it's like you're helping it along. So once it starts, then it can maintain that. So that's the idea. Okay, so this here is just that, to pulse it. We have another LED that's amber, just to show us the pulse is going to the generator. Okay, so the generator is hooked up to a power diode. That's just to isolate from the system, obviously, because if it wasn't, it would be spinning the motor. So this goes to a 12 volt system voltage. Okay. Which again, as I explained, this is a previous version, that's why I redrew it. It's all messy. So this is a block diagram of the whole thing. So windmill or wind generator from a treadmill motor. This one is rated at 125 volts DC. It's a permanent magnet motor. 3,850 RPM at 20 amps. Okay, 3 horsepower permanent magnet motor. Okay, so from here, this is the power diode. Just to isolate the 12 battery system voltage. Or system voltage, not the battery. Battery is over here after the regulator, so that's separated as well. So what's connected to here is the solar, the grid tie inverter that's connected right to 120 volts AC, and the solar battery regulator charger for batteries. Okay, and the batteries are here. All right, so this is the solar, wind, grid tie and battery system. Okay, so this is the that boost, 5 volts DC. It's added when this is not producing enough voltage to do anything. So this here voltage has to be 10.8 volts or higher in order to start the inverter, start the regulator. Okay, and this, for example, cuts out the 14.2. This here is good from 10.5 volts to 29 volts DC. It never gets that high because the higher the voltage in here, that is going up to 14, 16, the more this is drawing, so it's regulating the load. Okay, so we're taking off this pulse signal or the voltage coming from generator once it starts spinning through a diode, okay, and to a biasing circuit. So this Zener, if you have Zener, this is same as just having a Zener diode. This is plus, this is minus. Okay, we're using a transistor because I don't have one. Okay, so without this bias, that means for biasing this diode, it will not work. So you need to have at least like a volt. So this here is my signal coming from the pulses. Okay, so it goes anywhere to like to 3 volts depending on the pulses. And so I have to adjust this so it comes in at about 2 volts or something. So if forward bias is this, and when it's forward biased, then this part works. This Zener, once it's the voltage is over 8.5 volts plus the 0.7, so about 9.2 volts, turns on this Darlington pair or Darlington configuration transistors, which turns on these relays. Okay, and that brings in the kickstart over here. So it starts pulsing to the generator. Okay, depending on the speed again. And then also there's the boost. So the boost adds 5 volts DC to the voltage. So this is about 6 volts when it's turning in this wind speed, but it's not enough to do anything. It needs at least 10.8 volts to turn on the inverter, the battery regulator. Okay, so this is just the bias. It's a feedback, a voltage divider, and a capacitor. So when we get to a certain speed based on pulses, this forward bias is this diode, so now this can work. So now it kicked in at about 13 kilometers an hour, so it's helping it to start up fully. And when it goes about I'd say about 20 kilometers an hour, once it's running, it's producing well over 12 volts. So that means at that time there's a cutout. So this, here's a cutout. Cutout. So this is the cutout circuit, goes up to here. Okay. So just cut in, minimum cut in, and cut out wind speed. So that it just takes these circuits out, the boost and the kickstart, by this and this contact. Okay, I just got the notification from my battery monitor. It's at 22 degrees, 22%. So its charging was down to 0 overnight. Okay, and that's about it. If you have any questions, write in the comments below, and I'll do my best to answer them. So again, next video is gonna be a demo of this circuit, because I already have it built, which is basically adding on to the original circuit, which was this here. So I added that, and this is scribbles all over, so that's why I redrew it. Alright, that's about it. All this ended up being a lot shorter video than it was going to be, because I was explaining the circuit as I was drawing. Okay, so long.